we go with 8.3, properties of rational functions. If we're talking about properties of rational functions, there's some vocabulary that we definitely have to touch on first. All right, so when we talk about rational functions, remember rational means that it can be in fraction form. So the first thing we need to talk about are what we call points of discontinuity. Points of discontinuity are where the x values do not exist. Another way to look at that is, because it's in fraction form, it's what x value makes the denominator zero. So when we talk about points of discontinuity, let's say I have y equals 4 over x minus 3. Our point of discontinuity is that x equals, what x value would make this denominator 0? 3. So that's our point of discontinuity. That's where x cannot exist. Yeah, because if you had this, that would put a 0 in the denominator, and you can't have a 0 in the bottom of a fraction, right? Okay, what about if I had y equals 2 over x plus 1 and x minus 2? So this is going to have 2 points of discontinuity. What would be one possible point of discontinuity? -1. Good, Brooke. And what about the second one? Good. Okay, again, there are places where x can't exist. So by saying that, let's talk about the domain to go with these points of discontinuity. The domain is, of course, your x values. So what I talk about for this first one, x can't exist at 3. That means my domain goes from -infinity to 3, and then starts back at 3 to infinity. So the only place it can't exist is right here at 3. If I was doing the domain for this one, the domain would start at -infinity, go to -1, jump over -1 to 2, jump over 2 to infinity. So if you have 2 points of discontinuity, you're going to have 3 pieces to the domain. If I have 1 point of discontinuity, I have 2 pieces to the domain. One more than the number of points of discontinuity. Okay? All right. Next vocabulary. Vertical asymptotes. Now I know you already know what a vertical asymptote is from the graph, right? If I can spell. There you go. All right. Vertical asymptotes are that line that your graph is approaching but can never cross. However, mathematically what they are points of discontinuity that do not cancel with the numerator. Another vocabulary word that I want to put right here is called a hole. A hole in your graph or in your function is a point of discontinuity where it does cancel with the top. All right, so let me continue explaining. If I had, for example, y equals x plus 4 over, let's say, 2x minus 1 times by x plus 4. First thing I want to do is we've got to find our points of discontinuity. The points of discontinuity. All right, x equals. If I were to set this first factor equal to 0 and solve it, I would add 1 over and divide by 2. So what is the x value that would make this one 0? If I take 2x minus 1 equals 0, I add 1 over and divide by 2, 1/2. So there's a point of discontinuity at 1/2. Here, what would make this one 0? -4. Okay. Now, do either of those factors cancel with the top? Yes. The x plus 4 does, right? So this one and this one cancel. So since they cancel, this will be a hole in the graph. This one will be our vertical asymptote. So if it cancels, it makes a hole. If it doesn't, it's your vertical asymptote. All right, so here is actually example number 1. I know. Example number 1, we're actually going to start with 18 through 22. We are going to jump back to the other ones, don't worry. 18 through 22, it says find the vertical asymptotes and holes. Say we have y equals. On the top, let's say I have 4x. On the bottom, I have x squared plus 3x. All right, so the first thing I have to do to the denominator is I need to factor that, right? First thing I need to do is factor it. What can I take out, or what's the greatest common factor of the denominator? X. So I can undistribute an x out of the bottom. Leaves me with x plus 3. So then my points of discontinuity. If I take my first factor, x here, and set it equal to 0, what's one point of discontinuity? Well, that is one of them. X equals -3, and x equals 0. Very good. So those are our 2 points of discontinuity. Do one of those 2 factors cancel with the top? Yeah, which one? Yeah, the x, right? The x, which is 0. This one cancels with up here. So since that cancels, that means this one is a hole in the graph. And that means that x equals -3 is a vertical asymptote. Now there is a second set of vocabulary words that mean the same thing. If you have a hole, it can also be referred to as removable. It's removable because it cancels. If it doesn't cancel, it's called non-removable. So sometimes they're going to ask you to find removable and non-removable, and sometimes they're just going to ask you to find the holes in vertical asymptotes. Let's do one more from the same section. Let's say I have y equals x plus 1 over x squared minus 1. So I need to factor the denominator. How does the denominator factor? Huh? How does the denominator factor? It's actually the difference of squares, but you can also put it in the x. If I put it in the x, I'd have -1 on top, 0 on the bottom, which would be, 1 and -1, right? So this is actually x plus 1 times x minus 1, difference of squares, right? So I have points of discontinuity at x equals, what makes the first one 0? -1. What makes the second one 0? +1. Which one of those factors cancels? Yeah, the x plus 1 cancels with the x plus 1 on top. No. Hello? Okay. That's fine as long as they understand that's what's happening. Okay. Yep, thanks. Bye. All right. Okay. So when this one cancels, that means that the one where our point of discontinuity is -1 is called a hole.
Please, junior high track, you are dismissed at this time for taking individual pictures. The group picture will be immediately after school. Junior high track is dismissed at this time. Thank you.
Yeah. Yeah, and that. I'm waiting till after. It's all right. It's good. So here, if the factor does not cancel, then this is the vertical asymptote. What are you guys watching that's so entertaining over there? Okay. So do we have questions on what a hole or a vertical asymptote are? That seems pretty easy. Okay. So obviously if I talked about a vertical asymptote, I probably should talk about a horizontal asymptote. So let's talk about that next. All right. For a horizontal asymptote, to find it mathematically, you are going to take the coefficients of the x, or the greatest, x exponent terms. So what I mean is if I have, for example, y equals 3x squared over 4x squared plus 2. What? The highest exponent term is x squared. So I need the coefficients that are on our x squareds, which is 3 over 4. So I will have a horizontal asymptote at y equals 3 over 4. You take the coefficients of the x with the highest degree. All right? So let's try another one. Let's say...
I have a question. I didn't learn my question from with the vertical asymptote.
Okay.
So why could the positive one cancel out the negative one?
Because they're not exactly the same. To cancel. I mean, it's the same thing if you're reducing a fraction, right? It has to be the same factor on the top as the bottom to cancel them, right, or reduce them.
But when the x equals -1, it could take out the x plus. It could take out the x plus 1, but why can't the x equals positive 1 take out the x minus 1?
Because they're not the same.
But neither are the -1 and the positive 1.
No. Okay, hold on. Just a minute. Gotta get that out of my way. All right, let's go back to here for a minute. They have to be exactly the same to cancel. So let's talk about this. The top factor is x plus 1. The bottom factors are x plus 1 and x minus 1. Right? Okay. Which factor is identical top and bottom?
X plus 1.
That's it. The point of discontinuity for that is x equals -1. Right? But the factor itself that is canceling is x plus 1.
So if there was an x plus 1 and x minus 1 there, then both of them would be included.
Correct. That is correct. I agree with you. Okay? All right. So let's try another horizontal one. Let's say I have y equals 2x plus 7 over 5x minus 1. I will have a horizontal asymptote at y equals, and the highest degree is x to the first, so I have y equals 2 over 5. All right, so here's the rule of thumb we're going to follow. If the exponent on x is the same, then the horizontal asymptote equals their coefficients. If the exponent on the top is less than the bottom, then your horizontal asymptote will be y equals 0. And if the exponent on the top is greater than the bottom, then you're going to have no horizontal asymptote. So let me explain that just a little bit further. Let's say I have y equals x minus 4 over x squared plus 16. You'll notice we have a higher exponent on the bottom, right? So really that says I have 0x squared over 1x squared. Well, what is 0 divided by 1? 0. So we have a horizontal asymptote at y equals 0. If I had y equals x to the third plus 1 over x minus 1, my highest exponent is x to the third, right? So then I take that coefficient, which in this case is 1, but how many x to the thirds do I have on the bottom? We have 0 of them on the bottom. Can you have 1 divided by 0? So this is no horizontal asymptote. Okay? All right, so let's go to example number 2. On example number 2, this is going to cover your 24 through 28. Find the horizontal asymptotes. Say I have y equals 4x squared plus 5x minus 1 over 2x squared plus 7x plus 2. Nope. Well, x squared is the highest, but how do you find your horizontal asymptote? Yeah. So our highest exponent is the x squared, right? It's these. Okay. So that means I have 4x squared over 2x squared, or I have y equals 2. So I have a horizontal asymptote at 2. All right. Let's do one more up here. Let's say I have y equals 3x to the third plus 7x over 9x to the third minus 1. 1/3. Very good. So right here, our coefficients of our highest degree are 3 over 9. So I have a horizontal asymptote at y equals 3 over 9, or 1/3. Okay? All right. We're doing all right before I go to example number 3? Okay, well actually before I go to example number 3, let's do this. Let's sketch a graph, or let's talk about how to sketch a graph. Sketch. You'll be fine. Sketch the rational graph. All right. So when you are going to sketch the rational graph, first thing you have to do is 1, find points of discontinuity. You need to have that to begin with, which means maybe you'll have to factor the denominator to figure it out. Step 2, find all holes and vertical asymptotes. Step 3, find horizontal asymptotes. Step 4, find X and Y intercepts. Step 5, sketch. Alright, so let's go with this one. Let's say I have y equals 4x over how about x to the third minus 4x? Alright, first thing we have to do is factor that denominator. Okay? Got to find our points of discontinuity. What's my greatest common factor I can take out of the bottom? X. Alright. That leaves me with x squared minus 4. I can still factor that further. How do I factor x squared minus 4? You can do the x, or it's the difference of squares, right?
Yeah, take out the square.
No.
X would be x minus 2.
It's x plus 2 times x minus 2. What this is right here is if I were to draw my x, negative 4 on top, 0 on the bottom. The sides are 2 and negative 2, right? They multiply to negative 4 and add to 0. All right. So points of discontinuity are at x equals, what's this first one? 0. The next one is x equals negative 2. And the last one is at x equals positive 2. Those are our points of discontinuity. Then, looking at this graph, or at this function, now get rid of this because we don't want to look at that right now. Oh, maybe. All right. Which factor cancels with the top and the bottom? It's where x equals 0. It's this factor of x, right? Cancels on the top and bottom? All right, so that cancels, which means x equals 0 is a whole. The ones that do not cancel are vertical asymptotes. All right, next thing I need are horizontal asymptotes. So going back to this function, my highest degree I have here is x to the third. How many x to the thirds do I have on top? None, over 1x to the third, which means my horizontal asymptote is at y equals 0. All right, so let's do what we have so far, okay? If I were to graph this so far, it says I have a hole at 0, I have a vertical asymptote at negative 2, which means that's a dashed line right here at negative 2. I have a dashed line at positive 2. And I have a horizontal asymptote at where y equals 0 so far. Oops, that's supposed to stay in line. There we go. Okay? So typically what would happen here is, you know how when we just had one vertical and one horizontal, it was in quadrants 1 and 3? So here, it's again going to alternate. So typically it's going to fall in the first, but then it alternates, misses this middle section, goes to this one, misses this section, goes to this one, and then misses the last one. So it goes every other one. All right. But we have a hole where x equals 0. So that means right here where x equals 0, we have a hole in our graph, and that's what we're going to draw, is a hole right there. Yeah. Okay? Because x can't exist there. All right? So, from here, this is how you would sketch the graph. All right, now, while I have this graph here, let's talk about the domain and range, because I think that's important. In the domain, The domain are your x values. And what we already talked about is where you have points of discontinuity, your domain cannot exist. So for the domain, it can't exist at 0, -2, or 2. And you want to start from the left. So as I go this way, it starts at negative infinity. It comes to -2 where it can't exist. So I have -2. I'm going to skip over -2. And then it keeps going until it gets to 0. Can't exist at 0, so I'm going to skip 0. Keeps going until it gets to this 2. It can't exist at 2. Skips over 2 and goes to infinity. Let's talk about your range. In this one, your range starts at the bottom and goes to the top. What is the owner? You have a horizontal asymptote at 0, so what do you think your range is going to be? Negative infinity to 0, 0 to infinity. All right, so one of the things I stayed away from on this example was x and y intercepts, because what is an x or a y intercept? What's an x-intercept? The x-axis, right? Well, look where I have an asymptote. Can that cross the x-axis? So are there any x-intercepts? Okay. What about my y-intercept? That's where it crosses the y-axis.
Yeah, 2 places. No, actually not, because there's a hole.
Exactly. When it goes to cross on the y, it's a hole.
He's talking about the dot line.
Oh, yeah, but like the hole is, you go into another, there's a
Why do
hole.
we draw circles and not leave it blank?
Because that's usually, typically what they do is they draw like an open circle when you see them. Yeah. All right, so here's the deal. Obviously, I'm not getting through everything today, and with people coming in and out, all right, I want you guys to realize that you are going to have to be responsible for what's going on. I'm going to record what I did talk about. The first couple of problems, it's going to ask you for the domain, points of discontinuity, x and y intercepts. So one thing I want to remind you is when you are looking for x and y intercepts, I'm going to add this very quickly. All right? To find the x-intercept, and I know you should already know this, plug 0 in for y. Right? And solve. What are you talking about? You're putting 0 in for y. So like if I have y equals x plus 2 over x minus 3, and I want the x-intercept, I put 0 in for y, and I solve for x. So I'd have 0 equals x plus 2 over x minus 3. I multiply this over to here, and it drops out, because 0 times all that is still 0. So I actually get an x-intercept at -2. Okay? To find the y-intercept, you're going to plug 0 in for x and solve. All right? Remember that for the x-intercept, you're going to be writing it as x comma 0. For the y-intercept, you write it as 0 comma whatever your y-intercept is. All right? Questions at all? Okay. As I said, I know some of you are going to be in class. Tomorrow's going to be a review day. Monday, we'll make sure we're understanding this because we got to build on it. Okay? Yes, sir. Why didn't you bring it?